Hi, welcome to this video looking at revision style questions and revision for upcoming exams for summer 2022 for negative indices and the difference of two squares. So I've picked two random topics for grade 5 GCSE maths from the Maths Watch. Okay, and that's the clip number in case you want to check out the video or videos for Maths Watch for GCSE 9 to 1 maths. Okay, so this is appropriate for both the foundation and the higher tier. But as I go through it, I'll be very explicit and say which paper it's likely to appear on, but this is appropriate for both tiers, for AQA, EdXL and OCR, and all the other international exam boards like IGC and CIE and WJEC and all the other exam boards. Okay, as ever, feel free to obviously pause the video, guys, try the questions first and then press play. Okay, this is question number 1. Part A, find the value of 2 to the power of minus 3. Well, the minus is the reciprocal, so it's 1 over 2 cubed. So 1 over 2 to the power of 3. 2 cubed means 2 times 2 times 2, which is 8. So the answer is just 1/8. Okay, the next one, 3 to the minus 2 is 1 over 3 squared. So the negative does what we call the reciprocal. Okay, so it flips the number or fraction. Okay, 1 over 9. Okay, 3 squared is 9. Next one, 5 to the negative 1 is just 1 over 5 to the power of 1. Anything to the power of 1 is just itself in maths, so 1/5. This one here, 10 to the negative 4 is 1 over 10 to the 4, okay, which is 1 over 10,000, okay. Okay, 1 over 10,000. Okay, this is question number 2, part A. Find the value of, okay, 2 to the minus 3 times 4 to the minus 1. Okay, so value means working out your answer. Okay, 2 to the minus 3, we got 1/8 from the first one, and 4 to the minus 1 just means 1/4. So 1/8 times 1/4 is 1 over 32. Okay, using the rules for multiplication of fractions. The next one, guys, 10 to the minus 2 times 2 to the minus 4. Well, 10 to the minus 2 is 1 over 10 squared, which is 1 over 100. 2 to the minus 4 is 1 over 16. 1 over 2 to the 4, which is 1 over 16. So the answer that we get, guys, is 1 over 1,600. Okay, the next one, guys, this one's slightly more easier because I can use the indices. 5 times 5 to the minus 3, well, it's 5 to the 1 times 5 to the negative 3. If I add the powers, 1 plus minus 3 is negative 2. Okay, 1 subtract 3 is negative 2. So it's 1 over 5 squared, which is 1 over 25. Okay. So that's using the multiplication law of indices. This one here, 8 times 2 to the minus 3. Well, 2 to the minus 3 is actually 1/8. So I'm doing 8 times 1/8. If I times something by its reciprocal, I'll always get the answer of 1. Okay. So this is a little random fact here, that if you multiply a number by its reciprocal or a number by its inverse, you will always get 1, okay? This is question number 3, guys. Write these numbers in order of size. Start with the smallest. Well, it's going to be 3 to the minus 2 first. Then it's 3 to the negative... Well, actually... it's going to be 0.3 next, sorry, because So let's just put a minus 3 there, sorry, so that's the first one. So cross off minus 3, then it's 3 to the minus 2 because that's 1 over 9, which is 0.1 reoccurring, okay. Then it's 0.3, then it's 3 to the minus 1. The reason for that is because 3 to the minus 1 is 1/3, which is 0.3 reoccurring. So the definition of the place value is that that has to be bigger than that. Then it's 3 to the 0, and then it's 3 squared, okay? So be very, very, very careful with these guys when you order indices, okay? So I think I made a mistake here initially by not looking properly. Question number 4, if 2 to the x equals 1 over 64, find the value of x. Well, we know that 2 to the power of 6 is 64, okay, by definition. Therefore, 2 to the power of negative 6 is 1 over 64. Okay, so x is equal to negative 6. Okay. And if you didn't know that 2 to the power of 6 is 64, then that's fine, but please do revisit and revise your general rules here of knowing your powers, okay, up to power of 6 or 7, let's say. Okay, we're now going to look at difference of two squares. Okay, so factorizing quadratics, where is the difference of two squares. Okay, question 1a, factorize x squared minus 16. So this is where I always have, right, x plus the square root of the number. So x plus the square root of 16, which is 4, times x minus the square root of 16. Okay. And if you expand that, then you will get x squared minus 4 because the middle term disappears. Hence why it's called the difference of two squares. Okay, y squared minus 9, y plus 3 times y minus 3. Okay, next one's slightly more trickier. X plus a half, okay, times x minus a half. Because a half times negative half is minus a quarter. So x plus a half times x minus a half. Okay. Next one, a squared minus b squared is a plus b times a minus b. Okay. For part D, we're going to have x plus 1 times x minus 1. Okay. This one we're going to have x plus a third times x minus a third. Okay. So it's unlikely that they will throw in fraction ones, but fraction ones could be used on the higher tier. So make sure that you're happy with that, okay? Because it's just square root of the same number, but it's a fraction. So x plus a third times x minus a third. Okay. This is question number 2. So these ones are slightly more trickier. X squared minus 4y squared. So it's x plus 2y times x minus 2y. Okay. Next one, 9x squared minus 16y squared, 3x plus 4y times 3x minus 4y. Okay. So I do appreciate that I'm not going a bit swiftly through this, but you can check by expanding the brackets together, okay? 4x squared minus 25y squared is 2x plus 5y times 2x minus 5y, okay? So hopefully that makes sense, okay, for that one. So 2x plus 5y times 2x minus 5y. Okay. So it's always taking the square root of like the first component and the square root of the second component and just putting it as that letter plus that other letter times that letter minus that other letter, okay? So it's always a positive times a negative, okay? 9a squared minus b squared, well that's 3a plus b times 3a minus b. Okay, so I'd appreciate that I am going through it fairly swiftly, but hopefully it's making sense. This one's going to factorize into a half x plus y times a half x minus y. Now these ones are unlikely to come up on an exam paper, but obviously never say never, so like it may appear on like a higher tier question, okay, that's testing factorizing your quadratics, okay, for that one. This last one, we're going to have x plus a third y times x minus a third y. Or y over 3, and then x minus a third y. So you're essentially taking the square roots of like each component, okay, a third, and then stick a y on at the end, and then close the brackets. Okay, right guys, we're now going to look at simplifying these, okay, so I may have to delete some of this here, so hopefully you've copied these down. If you haven't, then feel free to like rewind like the appropriate parts, okay. So I've got a bit more space. Okay. So part A, I've got like an algebraic fraction, okay, and I'm multiplying two fractions together. Okay, so when I multiply fractions, I times the top together and I times the bottom together. I'm going to have 5 lots of y squared minus 4, all divided by y plus 2 times y plus 5. Now we should recognise that y squared minus 4 does factorise into the difference of two squares, and this is what I mean by simplify. So it's writing it, this fraction, in its simplest component. So it's 5 lots of y plus 2 y minus 2 divided by y plus 2 and y plus 5. Okay, I can now start cancelling the y plus 2's together. So my final answer, and I'll try and write it a bit smaller here, is 5 lots of y minus 2, all divided by y plus 5. Okay, and that's in its simplest form. Okay, I can't cancel anything down any further. Okay, I can't cancel the 5 with the 5. Okay, because it has to be like a product. Okay, next one, guys. Okay, sorry about the lack of lack of space here, but hopefully you're able to follow me. Okay, so let's just do this one here, and then I have to delete it when I finish the question. So 3 lots of, okay, you've got a 3 there. Sorry if you can't see it very well. Okay, I've got a 3 there. Let's just put y plus 5 there. Okay, this is going to factorise into 2x plus 1 times 2x minus 1. Okay, and x minus 2. I can now start cancelling these, so my final answer is 3 lots of 2x minus 1, all divided by x minus 2. So hopefully it makes sense there. Okay. And apologies for obviously having to like delete it, guys, but I've got like lack of space here. So please do obviously like, pause it and rewind it if you need to. Okay, as many times as you like. Okay, again, factorizing top and bottom, I'm going to take a 4x out of the top part, brackets 3x plus 2. The denominator is a difference of 2 squares. Okay, 3x plus 2 times 3x minus 2. Okay. Okay, so that's going to cancel with that. So my final answer is 4x all divided by 3x subtract 2. Okay, for my final answer for that question. Okay, this one here, guys, I'll try and leave that there actually, so I've got a bit of space. Okay, the top part factorizes into 5a plus 4b times 5a minus 4b. Okay. The denominator factorizes into 2b brackets 5a minus 4b, which means that I'm going to cancel 5a minus 4b, so my final answer for question 3D is 5a plus 4b all divided by 2b. Okay. For that one. Okay. Right, guys, we are now going to solve equations involving factorizing difference of 2 squares. So solve 4x squared minus 16 equals 0. Now I can factorize it, or I can just solve it normally. If I add 16 to both sides, I get 4x squared is equal to 16. Dividing both sides by 4, I get x squared is equal to 4. X is equal to plus or minus. Okay, remember that when you have x squared, you are always taking the plus and minus root. So x equals plus or minus root of 4, which is plus and minus 2. Okay, so it has 2 solutions there. Okay, for part B, guys, 25x squared equals 1. Dividing both sides by 25, I get x squared is equal to 1/25. Taking the square root, oh, it should be a 1 there, not a 2. Okay. Okay, then I get x is equal to plus or minus the square root of a 25th. So x is equal to plus or minus a 5th. Okay, for that question. Okay, for part C, it's slightly more trickier. If I divide both sides by 49, I get x squared is equal to 121 over 49. Taking the square root, the positive and the negative root, okay, because it's squared. Remember that when it's a quadratic, it always has 2 distinct real solutions, okay, unless the discriminant is not equal to 0. But yeah, yeah, for that part, okay, so x is equal to plus or minus the square root, actually, so it's going to be plus or minus 11 over 7, okay, or 11 sevenths. And for part D, I'll do it up here actually because we've got a bit more space here. So we've got 9x squared minus 7. Sorry, 9x squared minus 9 is equal to 7. Adding 9 to both sides, we get 9x squared is equal to 16. Dividing both sides by 9, we get x squared is equal to 16 ninths. Taking the plus and minus root, okay, so x equal to plus or minus the square root of that, okay. which is going to be plus or minus 4/3. Okay, because the square root of 16 is 4 and the square root of 9 is 3. Okay, and then we keep the fraction obviously the same, so plus or minus 4/3 for that question. Okay, and that's how we solve quadratics, okay, involving the difference of two squares. Now, of course, you are able to factorize it and solve it like you would normally, but I just try to solve it like a normal equation to make it a bit more, like, make sense. But of course, you are welcome to obviously use the difference of two squares method by factorizing it and then solving the quadratic, okay, but this is the method that I like to use if I'm looking at solving quadratics involving the difference of two squares, just by normal rearrangement, okay, because it's just practicing solving an equation. But of course, I can't do this if I have like an a extra x term in my quadratic, because I can't solve that normally, okay. I would have to factorize it or use a quadratic formula or complete the square. Okay, for those of you doing like the higher tier, so completing the square and quadratic formula is how we solve a quadratic equation. Okay, right guys, that is the end of today's video, so thank you so much for watching and making it to the end. If you did find this useful, please press like, please subscribe to my channel if you're new, and lastly, please click that bell icon so you don't miss out on further videos and further uploads. But that's it for me today guys, thanks for watching, I'll see you for my next revision video. Okay, bye for now.